In this video, we'll cover spontaneous and non-spontaneous process. If you look at these examples over here, these all represent either a spontaneous reaction or a non-spontaneous reaction. Let's take a look at the ice melting. Does ice melt at room temperature? Yeah, I hope so. I mean, if you have like a cup of water with ice in it, you'll notice that it melts over time. So this is something that's not forced. It's not something that it just naturally happens. So something like this would be considered to be a spontaneous process. So let me write that down. So something like this would be a spontaneous process. Now, something like this ice freeze at room temperature. Have you ever seen that? No, I mean, it's going to take some kind of work in order for that to occur. It doesn't happen naturally, but we can somehow manipulate it so that it can potentially happen. And so, therefore, this requiring work, some kind of work needs to be done for this process to occur. This would be considered to be a non-spontaneous process. Here's another example. Your diamond. So I'm wearing a diamond ring today. Yep. And also this diamond is advertised as that it's going to last forever. But you'll notice later on, if you live maybe few thousand years, you'll find out that diamond isn't forever. In fact, the diamond will degrade into what is called a graphite. Now, it will degrade into graphite, but it takes quite a long time. But either way, going from a diamond to a graphite, this process is naturally occurring. So this is considered to be a spontaneous process. Okay. So in other words, we can go ahead and just whip out a definition, and that would be that the spontaneous process is a process or reaction that occurs naturally, and a non-spontaneous process is a reaction that doesn't happen naturally, but it is driven by a continual input of energy from some kind of external source. It's not going to just take place, it needs to have some work done. So I have given all these examples. I want you to note that even though this may be immediate, meaning that a spontaneous process in which ice melting, it's very immediate. It happens within a few seconds and maybe a minute or two. It starts going. But for a diamond to go into graphite, that takes a long time, even though it's a spontaneous process. So spontaneity does not determine the rate. So they're different. So please refrain from thinking, okay, if something is spontaneous, automatically, a lot of people think that it's automatically fast, and that is not true. Here is another image that shows a spontaneous process. In the left-hand side, you see a container with gas. Okay, and the gas, if this valve is open, and you'll notice that it all sort of distributes to the right side, and it evenly distributes left and the right, and that's considered to be a very spontaneous process. In order for this to get pushed back into one container, which is not likely unless it's somehow forced, then that's considered to be a non-spontaneous. So arrow going in the other direction shows non-spontaneous. In other words, we can say that evenly distributing molecules is considered to be a spontaneous process for gas, evenly distributed. What about for heat? Heat, say this is a hot, like a block, and this is a cold block, and when they come in contact together, the heat naturally flows from the hot to the cold. You don't see cold becoming colder or heat. There's no heat for the cold to transfer to the hot areas, from hotter to the colder objects, and that happens spontaneously. And in other words, we can say evenly distributing this thermal or this energy is also considered to be a spontaneous process. So I really want to note this: evenly distributing molecules and evenly distributing this energy will provide a spontaneous process. Next, we'll go ahead and describe how matter is redistributed. So how is this redistributed when it comes to temperature or even molecules when the following spontaneous process take place? So all of these three are spontaneous. So think about it for a moment, how these matter are distributed. Come back and check with me. Okay, first, the solid sublimes, or this ice, it looks like ice. It's actually carbon dioxide. Carbon dioxide solid is smoking out. Okay, so what's happening to the molecules here? So there are little tiny molecules here of carbon dioxide. They're all condensed together in a solid form. When it sublimes, what happens is that solid turns into gas. So this is my gas, and then so the molecules are more spread out. So what's going on here? This is a spontaneous reaction, so we can say that in here there is molecules are evenly distributing. So we can say that, like previous example, that it is a spontaneous reaction. I'm going to skip on over to C and then come back to B. A drop of food coloring added to a glass of water with a uniform color. So you see it, it doesn't have any droplets, but once one dye is put in, you notice that it evenly distributes all over the place. So we can say that the dye is actually the dye molecule are evenly distributing. And so we can say that this is a spontaneous process. Now the second one, the B, you might not have noticed that this is gas condensing. What does that mean? It means that you have water droplets, water gas, here out in or on the surrounding. And then you introduce a really cold cup. And that cup, what happens is that this water molecule that's outside will come in contact with the cup, and then they form this droplet. So H2O is now liquid. So condensing, that's H2O gas forming into a H2O liquid. So you might think, well, this is a gas. They're all evenly distributed, and then now they're sort of coming together. So you might wonder, well, how is this a spontaneous process? But in real life, you'll see that it's not forced. It's it just happens, right? Well, we can say that this is still a spontaneous process, and I haven't provided the reason why. And the reason why this occurs is because gas condensation is temperature dependent. So because there's dependent on temperature, it is a spontaneous process. So it's not everything is about evenly distribution, evenly heat. Okay, it also depends on this temperature, and we'll go more into details later on in different videos. Here's another learning check. Describe how energy is distributed when a spoon at room temperature is placed in a cup of hot coffee. So that's my coffee. It's decaf with lots of sugar. Anyways, here is my cup. And here's my spoon. And the spoon goes into the cup of coffee. And it's hot in there. So what's going on in there? it's hot here, and here's my cold spoon. And the hot there will be a thermal energy transfer from hot to the spoon, right? So there will be a energy transfer from hot water or hot coffee to the spoon. So there is that spontaneous process because this hot is transferring to something cold.